problems. And the third one I thought got a little bit less attention, but this was creating an RL environment for language models to solve blackjack. So this idea of search has been around since Norvig, since the 80s, but it's been getting more attention as something that will play a role when we build models essentially that can reason. So when I was thinking about search, I thought of a really interesting problem that I saw when I was learning about algorithms in undergrad. This is God's algorithm. So solving a Rubik's Cube is famously an intractable search space. There's quadrillions of different combinations, and finding the optimal path between some cube and the solved cube is an NP-hard problem. So the idea here was that there would be God's algorithm, and what would be the lower bound of God's algorithm. This took 35 years of compute time even to solve, and so there's this really cool website about that. So that's kind of the motivation for why I think this might be a fun sandbox to see how our language models reason. So why would we even expect a language model trained on text to generalize to Rubik's Cubes? Well, we probably don't, but I thought of two things for why we might think this. The left one is some research by cognitive scientists showing that when you give tasks like Raven's matrices, language models encode the same biases as humans do. So maybe that can generalize to Rubik's Cubes. And the one on the right is essentially building better web automation by adding a value state on top of search. So I've thrown a bunch of research at you just to tell you why I think this is an interesting problem to do, and then I'll show you this mainly kind of like a fun UI. So what I did here was I have this kind of prompt, and I have the Rubik's Cube state in text, and then I tell the language model you can do these kind of 12 different operations on that cube, right? So these are the different faces that you can shift. So when we say generate nodes, what this will do is it'll generate different, essentially, chain of thoughts, and then it'll extract the move that the language model will make, and then it'll perform it on the cube, and then it will send it back to the language model if it wasn't correct with a new prompt, right? And then you can generate new moves. So you can see we generated 3 here. This purple one, it selected the best move. So what I gave it was I took the cube and I turned the right face and then turned it back, and that was correct. So, okay, cool. Okay, so the next thing I'm going to show you is we're going to kind of lower the amount of paths that we search, but we're also going to expand automatically, and then we'll reload. So the second one, the second cube we're going to look at, this is one of the hardest cubes you can have, so it takes 20 paths to solve, and so we're just going to let it generate. Okay, click on it here. So it's just going to generate, and it's going to ask the language model which turns are you going to make. It makes those turns, it verifies them, and asks it again. If the language model can find the correct cube, this will stop. So we'll just let it run for a little bit, but this is mostly to show how difficult it is for a language model to prune the paths and focus on the correct way it's supposed to go. So it's really important when you're using models that have a very complex search space to actually have something that guides that search space. So I don't think that this will solve it. We're using GPT-3 here, but I don't want to kill my credit card. So awesome. So yeah, so I played around with some extensions, see kind of self-evaluation to try to prune the search space, but mostly was focusing on the UI side.